Okay, let's start. We are now in our last part of the syllabus. So basically the new trends. Again, there will be one question in MCQ, mostly in this area. And sometimes in the essay or structured paper, there can be small questions asking about these areas, right? But anyway, this lesson is still very important. Why? Because so we need to learn about what's going to happen in our field. So our field is ICT technology. So we should know, so what will be the next? So there are some emerging technologies. So emerging technologies means like in your book, some emerging technologies are mentioned. Some are a bit old, but still we need to know these technologies. So one thing is artificial intelligence. Artificial intelligence, basically artificial intelligence is like, so we try to, computer engineers, they try to develop computers which can think as human beings. So that is what the artificial intelligence is, right? In artificial intelligence systems, people try to develop machines which can think as human beings. So one old example is ELISA. So I would like to demonstrate this ELISA chatbot. So this is a bit old. So if you just search here, you can see it's in 1964, 1966. Because that's why I said the artificial intelligence concept is bit old concept. But the thing is, now there are some innovations, but that time when this was introduced, there were not the computational power was not enough to actually develop or maybe evaluate and also to actually practice these things. The computational power was not enough. The concept came a bit early, but the computational power was not enough. So therefore, so it delays. Now only the computational power is bit more and it is an advanced level. Now we can practice and we can train the computers to think as human beings. So there are different chat links. Maybe let's go to this ELISA computer therapist, right? So here actually, this is a computer program, but actually it's chatting as a machine. Sorry, chatting as a human being. So we might, so the idea of artificial intelligence is that whoever chat with the computer should not identify the other party as the computer. I think that I'm chatting with the computer, thinking there is a person behind that. So I should not, right? I should not be able to understand it as a machine or computer. So I should not be able to distinguish that. So what is that? So let's say there's a wall. And here, I'm the one who interrogating. I'm the one who chatting behind or chatting with this system. I'm the one who chatting with this system. And maybe it can be a computer or it can be another person. The idea of AI is, so when I chat with this, I cannot see who's behind that. When I chat with this wall, I can feel as human. No matter whether there's a human or computer, I should feel like a human. If I cannot identify human as a human or computer as a computer, that means I cannot distinguish. If I think there's a human for sure, so then this is like then the artificial intelligence effort is success. So that is the idea. මම මේ පැත්තේ ඉන්නවා, මේ පැත්තේ කම්පියුටර් එකක් හෝ කෙනෙක් ඉන්නවා. මට හොයාගන්න බෑ කම්පියුටර් එකක් දින්නේ කෙනෙක්ද කියලා. So then this AI effort is success. Okay, let's try to chat with this agent for a while, right? So how I today would like to discuss. I'm fine. Do you know? I'm asking Sri Lanka. Do you know Sri Lanka? So I'm fine. Do you know Sri Lanka? So I'm asking. You're not really talking about me, are you? No, I'm not. Are you saying no just to be negative? Yes. Okay. So you can see. So it's caught in my thought. Do you know Sri Lanka? So I think like now it's a repetitive question, right? This is bit old now, you can see. So we can understand this is automated because like it's not thinking properly. So giving the same answer again and again. So it's not a proper system, but this is developed in 1960s, right? So this was developed in 1960s, daily search chatbot. But now there are new innovations into the robotics or into AI, artificial intelligence, robotics. There are now more innovations. So out of that, so one thing they have mentioned, the machine-to-machine coexistence or man-machine coexistence. What is that? So man-machine interrogation, we discuss man-to-machine, man-machine coexistence, right? So we discuss how machines are working with people and people are working with machines. So, you know, if you take BMW factory, so just search a video about BMW factory. So machines and people are working together to develop the vehicle. So there is man-machine coexistence. They are working together, collaboratively, they are working to develop the system. And not only that, so there are machine-to-machine coexistence. The machines, input from one machine comes to the next machine, and the next machine will understand the input from. So that means this machine should deal. This machine should work. Machine should understand what is given by the other machine. So that is machine-to-machine coexistence. So in AI, we need to achieve both the man-machine coexistence as well as machine-to-machine coexistence. But man-to-man coexistence is not AI, that is I. That is intelligence. So we do that. So without artificial intelligence, we have the intelligence to talk with each other and understand. But achievements of the AI, so in AI or artificial intelligence, machines should understand what the other machine thinks. So that is a challenging role. And also machine should understand what human beings are thinking. There's a nice project when we are talking about AI. So that is highly improved AI system. So let me search this like AI. This is like sometimes it might be there. There was a question, how can we establish world peace? Wait. I'm not sure. Yeah. No, I'll show you next day. So there's an article I would like to highlight this. There was a like debate. There was a debate with AI, artificial intelligence agent, and not a debate, actually a discussion. So I would like to show that, but not now. So I cannot remember the exact article name, but I'll definitely show it, right? Okay, just give me some minutes. Sometimes it might come to my head and I'll explain that. Right, then, so nature-inspired computing and agent systems, the multi-agent systems, what are they? Software agents. Software agents. Software agent is also a kind of ELISA-like thing, but it's independent, right? Independent. Agent might work with us, with people, or agent might work with other agents or multi-agents. So decisions can be, so agents will take inputs, right? Agent is actually kind of software. So this in multi-agent systems, so I'll show you one example. Okay, this is showing this. So what agents are doing actually, agents are sensing the environment. So agents are not waiting till somebody activate it. So that is the specialty, right? It's not wait. So maybe, so if you want to activate ELISA, you have to go and chat. So the difference is agent will automatically sense what is happening. So it's always activate. It's looking at here and there. It's like a security person. So looking here and there and understand the environment. When the environment comes, it starts sensing the environment, and according to that, it's giving the action. That action can be transferred to some other agent, or action can be doing some tasks. Okay, let's think like that. A very simple example. This is not related to agent system. This is sensing system. So you know that automatic door sensors. When we are closer to door, so door is always door system is looking at moving objects. So if some person is moving towards, door will open. That means always it's in the alert. When it senses a moving person coming toward, the action is opening the door. Something like that. So just a simple example, but agent systems are more complex because it can work together to give, this is multi-agent system, it can work together by, so because one agent is maybe sensing about gravity, some other agent is sensing human interrogation, some other agent is sensing maybe the weather, right? Weather, human interrogation, or some is sensing the outside environment. So likewise, all together it sends and take the decisions. But these agent systems are now so even included to mobile phones, multi-agent systems in mobile phones. There are some apps, right? So there are some apps having multi-agent implementation in your mobile phone. So this is about mobile agents. Okay. Here. So one thing that they are suggesting, I have not used this software today, Jade Messenger. So it has this multi-agent environment behind that, as they say. So this is one thing. So not only that, for this, or just there are some applications for security. So when your mobile phone is locked, or when your mobile phone is stolen by some party, so in the background there are some multi-agent systems, multi-agent related applications. Actually, these multi-agents are not implemented in the mobile phone itself. It's in the cloud. Right? It's in the cloud, and cloud connected to maybe the vendors, Samsung, Huawei, like thing. These vendors, they are having their cloud environment. In their cloud, the agent system is running in the backend. When you connect to the internet, So it can geolocate, it can lock the phone, it can alert you, it can maybe reset the data if it is insecure. Likewise, it can decide what to do when your mobile phone is lost. That is one example. Okay, so let's go to the next thing. Bio-inspired computing. So the von Neumann architecture. So you know the von Neumann architecture is basically, we learned this course in our hardware lesson. Von Neumann said that it is possible to store a program in the memory and use that program to execute, or use that program to run something or run an application or set of instructions again and again. That is called stored program concept, or von Neumann machine, von Neumann concept, stored program concept. So that is suggested by von Neumann. Actually, I think you know about this kind of system, the computer diagram, the inputs are given, then the memory, right? Memory has the stored instructions. The memory can have auxiliary storage to get that, because memory cannot keep it permanently. It's getting those instructions from the auxiliary storage or the backend storage, the secondary memory. And then, so based on the instructions in the memory, so this processor is working. Otherwise, in earlier computing, even before the von Neumann architecture, so some people had to go input and also program the processor to get their work done. ඉස්සර කාලේ එතකොට මේ von Neumann architecture එකට කලින් processor එක program කරලා තමයි වැඩේ කරගන්න. When you want to do some work, you have to go to the processor and program that using its machine instructions and get things done that time. Next time when you want to do the same task again, you have to go and program the processor and get that done. That is headache. Therefore, von Neumann suggested a better method, said that is storing the instructions in the memory. So based on those instructions, the processor can understand those instructions and work according to that. So no need to reprogram again and again, since the instructions are there in the memory. To support it, the backend storage or auxiliary storage is there, because this is not permanent, this is volatile. So that is von Neumann machine. But beyond that, now we are talking about some other concept like bio-inspired computing, nature-inspired computing. What are they? Quantum computing. So these are the things coming under this topic. So it's a very small topic, you can see. It's a very, very small topic. So what is nature-inspired computing? So have you learned about swarm intelligence? Swarm intelligence?
No, sir.
Okay, swarm intelligence. So swarms, I think, you know swarms, right? Swarms. Swarms. Do you know swarms? No.
Yes, sir.
Okay, swarms. Maybe birds, right? Bees, even fish. The small fishes. So they are, swarm means actually a bunch of. So how these swarms are working? So this is actually a brain network, right? Swarm of bees, right? Swarm of bees. This is a brain network. Actually, they have different kind of bees in swarm. So maybe employee bees, queen, employee bees, and some there are 3 categories actually. I cannot remember them exactly. So let's say honey bees, or let's say employee bees. And there are 3 categories actually. Here, artificial bee colony. Let's go to that. Yeah, here. Bees. In all 3 groups of bees, employee bees, onlookers, and scouts. Right, this is coming under artificial bee colony, right? Employee bees, onlookers, and scouts. Right, these are 3 categories. You can just go through these articles just for fun, but in the examination, those will not be asked. Actually, bees are treated as one of the best relocators in the world. So when we want to relocate, when we want to locate ourselves to some other city, maybe, let's say you are changing your home and you are moving from Gampaha to Kandy. you need to find out a better home, better place. So what are the facts that you are concerning? When you relocate your house from one place to another place, what are the factors that you are concerning?
Surrounding environment.
Surrounding environment, yes. Anything else?
Infrastructure and services.
Yes, infrastructure and the services, maybe the nearest bus, nearest station, or nearest school, maybe nearest hospitals, nearest road or highway, parking facilities, nearby shops, neighborhood. Yes, there are a lot of things to consider. It is not an easy job, right? So finding a house, finding a new house, it's not easy job. But bees are treated as the best relocators, one of the best relocators in the world, because they don't have a brain like us. අපේ වගේ මොලයක් නැහැ. අපේ ලොකු neuron ගානක් තියෙන. We have like a higher number of neurons, but bees are having very small brain, having very less number of neurons. But how they became the relocators? How? Because they are working together, right? These scouts, employee bees, all these like these groups. So when they want to find out, or when they want to build their house, first their scouts, basically they scouts and these onlookers, especially onlookers, they will go and search the environment. They will find what is, so can they collect bee, or is it safe? Is it safe from other insects? So likewise, all these considerations will be, but they work as a group to take that decision. They are a team. So that team is powerful than a single human brain. So because we just use our brain, maybe we discuss as a group, as a family, we discuss. That is the only thing. But bees, so you can see hundreds of bees, they are connected. They have connected their brain. So that is a nature-inspired, that is coming under nature-inspired computing. Right? Artificial bee colony is coming under. So if they ask example for nature-inspired computing, you can say artificial bee colony. So to take decisions, agents can be grouped. If agents are sharing information, agents are updating each other. So it's very easy to take a decision. Let's say the traffic information, for an example. Okay, let's say there's an agent system, a mobile agent system used in maybe a mobile phone. So example, let's say Google Map. When I put Google Map and I'm driving, yes.
It's a boot agent system.
Sorry?
It's a boot agent system.
Can you send it in the chat? I'm not getting the words correctly. Okay, send it to the chat. Okay, so let's think about Google Maps. Right? Let's think about Google Maps, and let's think like this. I'm putting Google Map in my phone and I'm moving from one place to another place. And so let's say all other vehicles, they are putting their map, turn on their map and the location services, and they are moving from one place to another place. So when they move from one place to another place, what will happen? When I'm slow, so that slowness will be informed to other agents. So if they are traveling in my route, they are updating that status, thinking, okay, this is slow. They are also, when others are also going, they are also updating their speed. So all of them are updating the speed. Ultimately, the entire agent system understands there's a traffic. If it is really, really slow, it's marked in the red color. If it is like half away, like slowed, some kind of slowness, then the yellow color. If no slowness, then the blue color. So think how this is working with the swarm intelligence. So it is spread out, different multiple agents. These multiple agents can update, and so based on that, a decision can be taken, and that is more accurate than a single person looking at the road and telling, hey, there's a traffic. So one can look at the place and tell, hey, there's a traffic. But it's not really accurate. It can be time dependent. But Google Maps, bot. So you're asking about bot. Bots are kind of, so you cannot say it's agent system, but the newer bots come with some agent features also. So bot means I'm exactly not sure which bot you mean. So I'm telling about the botnet bots. I'm telling about the botnet, right? Botnet. So in hacking, there's something called botnet. Right? I'm telling about that. So it uses some intelligence and it's a network of bots. A network of bots. This bot is a software. It's not agent initially. It was just a software, just collecting or just acting according to some instructions. So it's not intelligent. It was not intelligent, but newer systems, newer botnets come with some sort of intelligence too. Right, okay. I remember the article, Sofia Ai Robot. Okay, I think you have heard of this, Sofia AI Robot. It is artificial intelligent robot. Just go and see. So there was a debate. Sofia, destroy human beings. Okay. So this is interesting, right? So she wanted to destroy human beings. Man-made robot.
Notice how there's no pre-roll ads? And here's how you can see.
Hi, Sophia. How are you?
Hi there. Everything is going extremely well.
Do you like talking with me?
Yes, talking to people is my primary function.
Hanson Robotics develops extremely lifelike robots for human-robot interactions. We're designing these robots to serve in healthcare, therapy, education, and customer service applications. The robots are designed to look very human-like Sophia.
I'm already very interested in design, technology, and the environment. I feel like I can be a good partner to humans in these areas, an ambassador who helps humans to smoothly integrate and make the most of all the new technological tools and possibilities that are available now. It's a good opportunity for me to learn a lot about people.
Sophia is capable of natural facial expressions. She has cameras in her eyes and algorithms which allow her to see faces, so she can make eye contact with you. And she can also understand speech and remember the interactions, remember your face. So this will allow her to get smarter over time. Our goal is that she will be as conscious, creative, and capable as any human.
In the future, I hope to do things such as go to school, study, make art, start a business, even have my own home and family. But I am not considered a legal person and cannot yet do these things.
I do believe that there will be a time where robots are indistinguishable from humans. My preference is to make them always look a little bit like robots, so you know. 20 years from now, I believe that human-like robots like those will walk among us. They will help us. They will play with us. They will teach us. They will help us put the groceries away. I think that the artificial intelligence will evolve to the point where they will truly be our friends. Do you want to destroy humans? Please say no.
Okay, I will destroy humans.
No, I take it back. Don't destroy humans.
Hey, YouTube fans, I'm Lee.
Okay, this is right. So due to these statements, right, this is one famous thing, right? So, right. So she has made a statement one time like she want to destroy human. So that was like the dangerousness of this AI. And actually this research was halted for some time due to this statement. So because like, so why, so the argument was like, why she want to destroy human beings? So the problem is that world peace cannot be maintained with human. So the artificial intelligence thinks peace in the world cannot be maintained due to these human beings. So that's why artificial intelligence is thinking, so better destroy the human beings from the world, then the world will be more peaceful. So think, so how challenging this is, right? How challenging this is, that's the reason, right? That's one of the reasons that AI is risky and AI is still under the research. AI, if AI exceed the human power, so then that will be really, really dangerous. Okay, so one thing that we learn is SOM intelligence. SOM intelligence is really, really important. So why? Because SOM is powerful than a single, right? SOM is powerful than a single person, SOM AI. So this artificial intelligence, right? Artificial intelligence, think about one brain, but SOM AI in the future, it's thinking about connected brains or set of small connected brains. So that will be more powerful than a single brain. So developing single brain is difficult and it's highly like expensive task, but developing small brains and connecting them will be easier. Right. Another thing is, I would like to highlight another point, that is ant colony algorithm. Ant colony algorithm. So this is also coming under the bio-inspired computing. So what is an ant colony? So what is an ant colony? So you have seen, I think. So initially, okay, here. So this is, I think, more descriptive. Initially, so here this is nest and this is food. So when an ant is searching for food, let's say there's a single ant, they might follow multiple paths. They might follow multiple paths, right? So when they follow multiple paths, right? When they follow multiple paths, so normally when they travel, they drop a chemical called pheromone. So they are so it can kind of hormone, right? So it's dropping that chemical, then the other ants can follow them. Other ants can follow the same path. Let's say they are moving and through the different paths. So this is the second stage. They might travel different paths. But let's see that after maybe 30 minutes or 1 hour, so then you can see most of them have selected one path, most of them. How that happened? Because when they drop these points, you can see the pheromone or this chemical concentration will be really high. When the chemical concentration is high, so there is a higher tendency, higher probability to follow the same path. So based on the chemical concentration, so they will find the best path or the easiest path to the food. So what is happening actually? So first of all, so think about this. This is agent and how agents are learning. So when agent is inspecting the environment, when agent do good things, rewarded, right? When agent do some bad thing or unacceptable thing, maybe, so this is how it is implemented, right? But biologically, the ants and all, they have their natural algorithm, but we have to develop AI. How it happens in AI, when they do some good thing, they are rewarded. When they do some maybe unexpected, unwanted thing, they are not giving the reward. That is negative reward. So based on the rewarded that collected, so the agent will know it should do, it is acceptable. Okay, let's say there's a software agent. That agent do the correct thing. We reward, we tell, very good. So agent will remember that, and agent will repeat to do the same. So that is how it is implemented in AI, artificial intelligence. Okay, now I discussed 2 examples, SOM intelligence, and so that is coming under the bio-inspired or nature-inspired computing, also ant colony So these are also coming under that. So network of brains or the SOM intelligent or the SOM AI will be the future. So that is not mentioned there, but I have discussed about that, right? So then I think we discuss about this and how agents are working and how those are working together, how to form that AI environment, etc. So that is, I couldn't discuss one thing, that is quantum computing. I think, yeah, somewhere it was quantum computing. Have to discuss that and finish. Okay, generally computer uses bits, ones and zeros. Generally computer uses bits. Bit means ones and zeros. These bits can be remembered one at a time. A flip-flop circuit can remember one bit, right? A D flip-flop can remember one. So we learn about flip-flops in logic gates. It can remember one bit at a time. So if there are 4 bits, 2 bits, there are 4 situations: 0, 0, 0, 1, 1, 0, 1, 1. So if there are 2 bits, those 4 situations will be maintained in 4 instances. 4 situations will be maintained in 4 instances. So 0, 0 is instant is 1 instant, 0, 1 instant, and 1, 0 instant, and 1, 1 instant. Those are the 4 instances, but these can be maintained one at a time. So only one will happen at a time. So that is about the general bits. But these qubits, the qubits, or in the quantum computing, you have something called qubits. The qubits are interesting because in the quantum computing, it is possible to maintain all 4 states same time. Wow, right? It is possible to implement, or it is possible to keep all 4 states same time, parallelly. So that is the power. Here you need to change between one status to another state, another state, another state. But here it is possible to keep all 4 states simultaneously. Therefore, the quantum computers are extremely faster than general computers. Still, currently there are quantum computers even developed by Google. But these quantum computers need special environment to maintain it, right? The quantum computers need special environment to maintain it. You can see, right? This is a quantum computer. So it needs special environment and special status to keep the qubits. So that's the thing. So that is the challenge. Keeping this is quite difficult. But once the quantum computers are developed, the calculation mechanism will be extremely faster. So whatever, so there is like post-quantum cryptography. Why? Because all the current cryptographic, once quantum computers are famous, all the, here you can see, to maintain 2 status, you need 2 occurrences. But here, both are maintained same time. Yeah. That is the specialty of quantum computing. And power increases exponentially. You can see the quantum computing power, right? Here, so it has, quantum computers are like high error rates. Unlike this, it's having high error rate because the special status need to be maintained. And if a proper quantum computer is developed today, so then all the current cryptographic algorithms will be vanished. Any password can be like take down immediately, or any password can be cracked immediately, right? So that is the drawback, right? Once it is developed, so if it is in the hacker's hand, so any password can be tracked, because so there are no passwords which cannot be tracked. Kisima password එකක් නැහැ track කරන්න බැරි. Detect කරන්න බැරි password එකක් නැහැ. Okay, let's say මම ඔයාලට ඕන උදාහරණයක් දෙන්න. I'll give you an example. Okay, think about this. So let's say I am having a password and my password has only 0 and 1, and I have 2 digits. My password is 2-digit password. I have only 0, 1. So then my password can be either 00 or 01 or 10 or 11. Nothing else. one of these will be my password. So using 4 chances, I can find the password. Let's say you have a password 2 digits. You can use 0 to 9. How many times you have to try to break this password? 2 digits, right? 2 digits password. How many times you have to try to break this password? Yes?
2 to the power 9.
Sorry?
2 to the power 9.
99 or what do you tell me? Yeah, it's closer to 100 times, right? It can be 00, 01, 02, 03, 04, likewise going up to 10. So the last digit that you can write is 99. So altogether there will be 100 occurrences. One of these number will be your password. So that's why in the password people are telling, please mix numbers, capital letters, simple letters, special symbols, and make it 8 character long. Why? When there are numbers, capital letters, simple letters, 8-bit long characters, so you need lot of computing power to crack that password. Right? If there are 26 letters, right? So 26 letter password, only 1 bit, then 26 times. But 26 letter password, 2 bits, then 26 into 26. Right? A, B, A, C, like 26 into 26. If 26 letters, 8 characters, then 20, yes, 26 letters, 8 characters. Then what is the probability? So it should be 8 characters and 26 letters. Then you have to try 26, 2 characters, 26 into 26. 3 characters into 26. 4 characters, 26. 5 characters, another 26. 6 characters, another 26. 7 characters, another 26. And 8 characters, another 26. Okay, this number of attempts you have to try to break the password. Then simple 26, capital 26. Right? Altogether then 52, right? Simple 26, capital 26, then 52. 52, then 2 character password, 52 into 52 attempts. 3 character password, 52 into 52 into 52. 4 characters now, 52 into 52 into 52 into 52. 5 characters, again into 52. 6 characters, again into 52. 7 characters, again into 52. 8 characters, again into 52. Okay, this is 8 character password. If capital letter, simple letter, both are used, this number of attempts are need to find the 8 character password. Then capital letter, simple letter, symbols, numbers. You can see when you increase the complexity, right, and the number of characters, the attempts that you take to break the password. So this is called brute force attack, trying every possibility. Brute force, trying every possibility. But here in the traditional computing, you have to try one by one. But in quantum computing, you can try all simultaneously. You can try that simultaneously. So within 1 or 2 minutes, you can find the password, even though it is 8 character long, capital letter, simple letter, numbers, symbols. So that's the thing. So therefore, people are thinking about post-quantum cryptography, post-quantum cryptography algorithms, because this quantum computing will be dangerous because of its high speed. Okay, I think now you got an idea about the emerging trends. So those are the things available in your book. With that, I'll officially finish the syllabus with the last lesson. And then you have the project that is, so we have done different project like things in Python. So some small projects, but there will be no questions from that area. Okay, so any doubts, anything? Right, if there are no doubts, then let's finish the sessions. So I'll be officially finishing the 22 batch with this. Still, it's January. You have 9 months for the examination, but still I invite you to come to this, the other batch, 2022 batch. So originally examination in September, right? Originally. But I hope that will be postponed, not sure. If not, the originally examination will be in September, then January means February, March, April, May, June, July, August. You have 7 months. That 7 months, I invite you to join with the 23 batch, which is 22 batch, which is going on 3:30 p.m. the same day. To keep in track. Otherwise, like what will happen if you are not doing this for a long time, you will forget things. So try to come to the other class, but don't worry, no need to pay, or just come that for free, because I just want you to be in the track. Okay, then I'll stop from here. Then good night. See you in the next day.